I'm really thrilled to be here, delighted, and very, very proud to be celebrating Bielefeld's anniversary with you. So thank you very much for having me. I think the British word for it is I'm really chuffed. So, and I have spent more than just that year in Bielefeld. I've been here often with friends, and I feel a friend of the university. So thank you very much for having me. The topic is why big theory is here to stay, and you've already heard about it, but let's begin with, I think you now understand why I was invited. Perhaps it was a desire to have both pro and con. So yesterday in the evening we had a wonderful talk about fundamental theory and its importance, and I'm reputed to be anti-theory. So here are a couple of quotes. Cartwright is anti-realist about fundamental laws. They are not even approximately true. I think they're not approximately. I've always thought they weren't approximately true, but they were actually good. If you didn't try to make them true, they were very good at explaining. Okay. We find the philosophy of physics going anti-theory. Think, for example, of Nancy Cartwright. Okay, so, but today, I'm going to, as you've heard, I'm going to defend theory, and even big theory. Big, though, as we've just heard, not high, like grand social theory, Saint-Simon, Karl Marx, Judith Butler, or deep, as in fundamental, as in Einstein, Charles Darwin, or Francis Arnold. So big, well, big in the sense of wide. Just make sure I've got the same right slides up there that I'm seeing. As in lots and lots of theories, a good many middle and middling. By saying that the lots and lots include little and middling, I'm not taking the, I think it was the fourth line that we heard about in the introduction yesterday, that we should only have middle-level theory, but rather that I think we need everything, right? Including grand fundamental, high fundamental, and little and middling. Okay. So the reason is that this is what I was absolutely astounded by. Maybe you wouldn't have been so surprised as I was, but as a young person having studied physics and mathematics and then philosophy all together, and I loved quantum theory, and I was really interested when I was an assistant professor at Stanford in the uses of quantum theory, lasers. I loved lasers, and it turned out, of course, I knew nothing about lasers, having learned quite a lot about quantum theory. So quantum theory alone will not build you a laser, nor will it test the general theory of relativity. So while at Stanford, I was a participant observer on the Stanford Gravity Probe experiment, whose project leader was Francis Everett, and Francis spent 20 years, right, putting some gyroscopes into space, designing gyroscopes and putting them into space because they were supposed to they would precess. If GTR was right, the gyroscopes would precess due to space-time coupling. And what impressed me with this was it took him 20 years, and there are 20 volumes on his shelf of detailed theory of the design of the test, including these closest to perfection gyroscopes. So he had to learn a lot about the theory of fused quartz in order to run his test. So these need, they need lots and lots and lots of pieces, right? As well as teamwork. So you need teamwork from a vast set of theories of different sizes and sorts. So science does produce has wonderful achievements like these. Up in this corner over here is the Oxford knee, which was designed by my neighbor and others. Okay, so we have devices like those and models. All these, I think, are examples of theorization. You can't have a device that's not theorized. You can't have a model. Measures, studies, zillions of kinds of studies we do, experiments, what we call theories. When I'm talking theory here, I mean, Wolfgang Spohn just told me that a theory is a deductively closed set of sentences. Is that right, Wolfgang? Okay. Okay, so theories in that sense, and so forth. Okay, so if you want these wonderful achievements of science to be reliable, you had best employ lots and lots and lots of theory, of lots of different kinds and scales. So I'm happy with the importance and need for high, grand, and fundamental theories. What I never have been happy with was what I think of as grand takeovers. So here we have a famous physicist saying that it's quite possible, I mean, he envisages that we have a complete, consistent, unified theory. We might not get it, but this is, in his mind, a possibility that would describe all possible observations. Of course, we post-lapsarians might not see how it describes all observations, but that one theory would actually be the theory that describes everything. Okay. Here's another one in social sciences. Gary Becker won a Nobel Prize, and for theory aspects of human behavior which had previously been dealt with, if at all, by other social science disciplines, such as sociology, demography, and criminology. So he had one theory that was going to cover all of social relations. And I just don't think I've never seen any good evidence that it works like that. Now, it's not, though, just studies of people studying science and history, philosophy, sociology of science who argue this kind of thing. It is a recognized view about epistemology in general. So there's a field called social epistemology, and it says, well, it's not this, right? The Cartesian view that knowledge is in the mind of the individual, but rather knowledge is possessed by, and only possessed by in the first place, a community of knowers, and then you can derivatively assign it to an individual. Okay. Now, my view is simply Karl Popper, famous Karl Popper, writ large. Popper said that scientific work should be falsifiable. It should have enough content to actually say something. Now that's why I don't go along with Wolfgang's definition of theory, or I mean that's fine, that picks out something, a deductively closed set of sentences. Well, maybe it's sentences if sentences have meaning, but without all the rest of those little pieces it takes, the teamwork, I think that the deductively closed set of sentences don't have any content, and it's all the rest of the pieces that give content to it. So without big sets of lots and lots of theories of lots of sorts and sizes, our concepts are meaningless, and the equations and principles are contentless. I mean, what does this equation actually say? What does it actually say about the world? It depends on not it, but all these other bits of theorizing. So, he didn't like Marx and he didn't like Freud because he thought that their theories didn't have enough content. The way I look at it is it wasn't that their theories didn't have enough content, it's that there wasn't the surrounding bits of information and work and theorizing to give them content. And it might be that they are not good enough starting ideas for those additional bits of theorizing to be forthcoming. Now, I want to use today as an illustration something I'm much more working on lately than physics, which is development economics. And this is Angus Deaton, who won his Nobel Prize a few years ago, and I asked him about, could I start with what might be grand theories in economics? And I think they do have some. He suggests perhaps supply and demand or arbitrage, but then has more or less the view that I had. My guess is we have lots of little theories, often contradictory, and we switch among them according to purpose. Here's another economist, Danny Roderick, who says economic activity defies universal laws when economists embrace their expertise as a set of tools, not a grand unified theory. They can improve the world, well, we hope. Rather than a single specific model, economics encompasses a collection of models. It's always expanding, okay? The diversity of models in economics is the necessary counterpart to the flexibility of the social world. So, Roderick insists that economic activity defies universal laws, but when economics embraces their expertise as a set of tools, not as a grand unified theory, they can improve the world. So it's a very big set, though, of tools. So this is my picture of what scientific theorizing looks like. There's lots and lots and lots of different kinds of theories, all of which are necessary if you want to build something useful in the world. So my plan for the rest of the talk is I want to look at an egregious case of theory denialism, because I want to defend the need for lots of theory. And I'm going to look at a case in economics, and it's a case that matters in principle and in practice to people's lives and hopes, the randomized controlled trial, where theory is out in the interests of rigor, or so I'm told by advocates of randomized controlled trials in development economics. So I've been looking at what's said in defense of them as the major tool, and a major tool that allows us to dispense with theory, and it's really in the interests of rigor, they're urged. And I think that on analysis, there are two criteria that are being demanded for to call something rigorous. The first is that there should be a valid argument why the method can deliver the results it should. So all methods have assumptions that must be met if the method is applying correctly, and then you get some empirical results from the method, and there should be a valid argument why, if those assumptions are met, the empirical results imply the outcome. Okay? So valid argument. But the second requirement that they seem to be demanding is that the valid argument has warranted premises. So I have, in the social sciences, looked at lots and lots of methods for drawing causal conclusions, which is what the randomized controlled trials are about. What kinds of methods ensure that drugs do what you think they will, or that a social policy does what you think it will. So I've been looking at lots of methods, and lots of methods where there's a good, in fact, deductive argument that if the assumptions are met, then the empirical input implies the causal conclusion. So we've got a real implication: controlled experiments, natural experiments, instrumental variables models, econometric models satisfying special conditions, qualitative comparative analyses satisfying special conditions, causal Bayes-Nets methods, process tracing, derivation from theory. All these have a valid argument behind them, but they're labeled not rigorous. And then what is? Well, you already know. The randomized controlled trial is the most rigorous. This is from the British Medical Journal. Here's GRADE, which is widely used both in Britain and internationally for ranking evidence for social policies and medical policies. Randomized trial have the highest kind of evidence. Here's the United States Department of Education's What Works Centers. Randomized controls are their gold standard. Okay, and here is, I'm going to talk a little bit about this, JPAL, which is the Jamil Abdul Latif Poverty Action Lab, which is mostly manned by a number of MIT economists and is very interested. And I mean, these are the good guys. They're really deeply concerned about world poverty and know a lot about the countries that they're working in. Randomized evaluations are the most rigorous. Okay? And now here's the reason I thought I'd go into this, because it's very timely. Here are the three people who won the Nobel Prize in Economics this year, about a month ago. Banerjee, Duflo, and Kremer. And here's the citation. You see they have one for their experimental approach to alleviating global poverty. So they're helping, so it says, alleviate global poverty by, and then their new experiment-based approach, that is RCTs. Okay, and that they've won the Nobel Prize for this. Now here again is Angus Deaton, in a paper I've just looked at that he's got coming out, I think, this week. And one of the section headings is RCTs are rigorous and scientific. And then here's what he says about them. This rhetoric is rarely, if ever, justified. The adjectives are used as code words for RCTs, frequently so. The rhetoric appears to be successful, at least with funders. So, what's so good about RCTs? They have what we're told is they have, unlike all those other methods I listed, credible premises. Okay? Incredible because they're secured by design alone without the need for any theory. Okay? The claim is theory is inevitably unreliable. I don't understand how they can say that. I mean, they must mean it just inevitably unreliable if you're an economist, because they do rely on the physics. I mean, they think the physics ones are reliable. Okay, so we've had in the last decade in economics something called the credibility revolution. It was probably in part launched by Leamer and Sims, who wanted to have kind of analyses that combat whimsical nature of key assumptions. Assumptions means theory, I'm going to tell you that. Angrist and Pischke from LSE, the credibility revolution. You're not allowed to offer strong, you need support for your identifying assumptions, okay? Or Julian Rice, a philosopher of economics, econometricians often find one another's assumptions incredible. So all this has to do with credibility, whereas I said assumptions is just a code word for theory. So they don't want to import any theory whatsoever. So let's look at the RCT and its validity. And I'm going to just put up a bit of formalism, which is easy to follow, but don't worry. It's just that I want you to see that there is a valid argument. So what we most like to have is an individual treatment effect of a cause, which is, consider me. I mean, what would happen if I were subject to the cause versus if I weren't? Okay, that would be the individual treatment effect for the unit me. It's a counterfactual. It's the difference between the outcome I would experience if treated versus if untreated. Now, if we want the average treatment effect in a population, say, the people in this room, it's just the average of the individual treatment effect across all of us. Okay. Now, the bad news is you can't measure directly the individual treatment effect for any unit. Okay? You can't both subject me to the treatment and not and see what the difference is. But the wonderful thing, really wonderful thing about randomized controlled trials, this is from my point of view, not the point of view of people who say, they don't import any theory, but the wonderful thing is that you can measure an average of a quantity, even though you can't measure the quantity in any individual. That, I think, is amazing, okay? So here's a defense of what you can do with an RCT, and this is the standard defense in economics. They start with what's called a potential outcomes equation. You have the effect on the left, and a set of causes on the right, or things that contribute to the size of the effect. The one we're interested in is X. Well, there. It may or may not actually appear in the correct equation. It may or may not be a cause. The kind of causes we're interested in generally do not produce an effect on their own. They need helping factors, or beta, the interactive things that modulate whether and how much they can contribute, which are called support factors in philosophy, and interactive variables they are statistically. And then the W is a variable that stands for the sum of the net effect of all the other causes that don't interact with the one in question. Okay, so that's what you have. X is the focal cause, Y is the outcome, W is all the other causes except beta. Now, beta, as I said, you can see it tells you how much, if anything, X will contribute. It's one of the support factors, but it also turns out it's the individual treatment effect. If you look at it, it's the difference in the outcome when X equals 1, when you actually have the treatment, minus when you don't. So beta not only represents the support factors or interactive variables, it also tells you how much X contributes to Y, the net effect of all the interactive or moderator variables. Okay, so we've got that. Now here we have, suppose you have orthogonality in the study population, that is independence of the putative cause, the cause in question, from all the other causes. Then it's provable that the difference, look at the people who have the treatment under these conditions versus those who don't, take the expectation, And the difference between them is the expectation of beta. That is, the observed difference in means between the treated and the untreated population gives you an unbiased estimate of the study population average treatment effect. Okay? And if the average treatment effect is bigger than 0, somebody in the population had to have been helped by the treatment. Okay? So that's the point of that, is to show that here we have rigor and the sense of validity. There is a valid argument. You can start with, you've got a measured difference in the expectation between the treated and the untreated. You know what that is, that's phi. Then it's rigorously valid that phi is an unbiased estimate of the average treatment effect in that study population. What about credible premises? Well, there's the catch, right? Because this method's supposed to be have the advantage of credible premises. The 8 estimate is rigorous, so what's supposed in that derivation is that the study population can be described by a potential outcome equation, and this thing I called orthogonality or independence. But what about credibility? Well, actually, everybody just assumes one and never discusses it. They just assume you can represent the production of the outcome by a potential outcome equation. But then what about 2? Okay. Well, that's where randomization is supposed to be so wonderful, right? Random assignment assures that you have independence at the time of assignment, at base. Okay. So that's terrific. You've got the orthogonality that you seem to need for the population, except that you don't make the measurement then. You actually introduce the treatment then and make the measurements later on. And after that, anything can happen. And I was just looking at a description of a study where there was a random assignment of a new heart treatment to different hospitals. And as soon as the assignments were made, all the good heart doctors rushed to the hospitals that had the new treatment available. Okay, so RCTs turn out not to be so rigorous after all, because their premise of orthogonality is not so good. It needs lots of work, and it cannot be secured by design alone. Randomization doesn't do the job. You have to know things about what's happening afterwards. You have to theorize. Okay, worse, what about the conclusions you can draw? What the claims are that you could get rigorous evidence for? Well, you could have the 8 of x on y in a population you could, is phi, or x caused y in some units in that population, x causes y widely, maybe, or everywhere, or it caused y in some units, or it would or will cause y in some units in that very population, or it will cause y in some units in some other population. Those are the ones that you can get a valid argument about, and none of these. And yet, those are what we're interested in. So RCTs are good for post-hoc evaluation. You've got a fixed population, you wanted to find out whether the treatment worked there, right? Actually, you can get an unbiased estimate if you had orthogonality, okay? But often, you don't want to know about the population you studied, you want to know some new population. I think this is all fairly obvious and trivial and fairly widely accepted. So studies show results about the object studied. No amount of study design takes theory, right, can make a study give results about things not studied. So here we have Jamie Oliver, and he's studying some particular dish, but that's not going to tell him about any of these others. Okay. Now, let's go back to these 3 folks here. Recall, RCTs are supposed to produce reliable results, all by themselves, by design alone, without a load of incredible assumptions and models, i.e. without theories. So what are they really reliable for? Well, recall. These are the premises, okay? And that shows what I loosely have called it worked somewhere. That's what you can rigorously establish. Now, it worked somewhere. I can give a precise sense to that. What I mind is that we have a lot of loose talk in this domain, where theory immediately slips back in. So this is from the second paragraph of a paper by Duflo and Kremer, and I wasn't looking for something like this. It's not cherry-picked. I mean, I just noticed it. It says the benefits of knowing which programs work extend far beyond any programs or agencies, and credible impact evaluations can offer reliable guidance. So I think which programs work sure sounds something like it works in general or widely or always or something. I mean, which programs work? Impact evaluation is it worked somewhere. We evaluate what impact it had in a specific place. Reliable guidance seems to suggest it will work in some other populations, for instance, here in this population. Okay, so this is loose talk. And it's only the presumption that there's a lot of theory that would allow you to slide from one of these to the other. Now, if you read the rest of the paper, this kind of loose talk persists. So this is okay. The evaluation shows that the program was effective. Well, that's what you can do if you import enough theory to ensure orthogonality post-random assignment. Here's another one. Show that the children had a 23% reduction. That's okay. But this is worrying. It is possible to explicitly compare the cost effectiveness rather than what the cost effectiveness was. So okay. Now, this is not this is not unrecognized. This is a widely recognized problem with a randomized control trial. It's called, I think, misleadingly, the problem of external validity. But how do you get further? And Duflo and Kremer, again, they've got ideas about that. And one way to learn about generalizability, well, that is it works, which is what they seem to say, having just done their 2 RCTs, is to encourage adapted replications. Okay, but it doesn't help to just get more and more study results. There are more than 2,000, you all know this case, there are more than 2,000 swans in the Thames. They're all white. In the right season, there are more than 40,000 swans in the UK. They're all white. And still in Sydney Harbour, this is what the swans look like. So this is in case of what Francis Bacon, quite a long time ago, taught us induction that proceeds by simple enumeration is puerile. So piling up RCTs is not going to do the job for you. You need theory, okay, to get out of it. So when we are told X is reliable, we need to know reliable for what? And this is not as an idle philosophic question as we see with respect to RCTs. RCTs, even piled up, are not reliable for it works. It will work here. And as Duflo and Kremer admit, well, it will always be possible. In another adapted replications, you get some different results. Guided by theory of why the program was effective, then an RCT will go a long way. But look, they sweep a lot of under the rug with theory. I mean, first they want to throw it out, and then they say, well, if you're guided by theory, you can make wonderful use of RCTs. Theory must here be a way of alluding to the great set of theories of all sorts and sizes needed for reliable outputs. So how can you use theories to put RCTs to work, besides the bad way of trying to, by justifying an induction? I'll just tell you very briefly about something Ken Arrow did, how to get from short-run RCT responses to long-run. So, RCTs run for a very short time. You're usually interested in what might happen even in the same population in the long run, or an extension of that population. So there were health and tax RCTs, and the question is, what happens if consumers permanently face different prices or wages? And the RCT is a case where they face them temporarily. So a temporary high tax on earnings is thought by economists to be a fire sale on leisure. So it's an opportunity to take a vacation and make up earnings later. It's an incentive that's absent in a permanent scheme. So Arrow answered this question for the Rand Health randomized control trial using theory. And let me skip over how he did it, okay? It's in the interest of getting on. Just the point is that Kenneth Arrow used a lot of theory and modeling in order to put that randomized control trial result to use. Okay, and this very, very famous work. So what does it predict? What does it take to predict what a program will produce here? Theory, more theory, mostly not grand nor high, but small and middling and detailed. So recall the Stanford gravity probe, right, where I said there are 20 volumes on Francis Everett shelves, or what theories you need to build a laser that works. Now, getting policy to work should not be expected to be all that much easier, and I'm going to give you a simple example from development economics that I've looked at a while ago. It's the Bangladesh Integrated Nutrition Project, and this is going to be a mix of middling and low-level theories. There was a program in Tamil Nadu that was fairly well followed, and good evidence that it worked to improve childhood nutrition in that Tamil Nadu population where it was tried out. And it was to educate mothers about what we think makes for better nutrition for them before the child is born and for the baby. Okay? The same kind of program was tried in Bangladesh, and even 6 years later, there was little evidence that it was succeeding. So what went wrong in Bangladesh? Well, the post-hoc evaluation there said it was men and mothers-in-law. Here's the one of the reports of the post-hoc evaluation. The program targeted the mothers of young children, but mothers are frequently not the decision makers and rarely the sole decision makers with respect to the health and nutrition of their children. Women do not go to market in rural Bangladesh. It is men who do the shopping, and for women in joint households, meaning they live with their mother-in-law, as a sizable minority do, then the mother-in-law heads the women's domain. So the cause in Tamil Nadu, the cause of the better nourished children, was putatively described as educating mothers. But actually, that's not the description under which that project worked. When you bring theory in to think about it, it was the description on which that program worked was we were educating those who control what food is procured, control how the food gets dispensed, and hold the child's interest as paramount. Okay. That's the description under which the cause worked in Tamil Nadu. We only know that after the fact. It took some theorizing to figure out what was the right way to describe those evaluation results in Tamil Nadu. So the mix of theories used. Well, first there was data from the Demographic and Health Survey, which you see here. Then there was other kinds of theory, and more theory, where I'm using theory in my sense of abstract conceptualization, requires imagination. We construct the comparison group using propensity score matching. There's a lot of theory behind propensity score matching. Focus groups. How do you do a focus group? Most of us would be real rubbish at it unless we've learned some theory. And then, of interest, I like this, from these came the memorable quote, "We'll start doing that." What they were advised, once our mothers-in-law have passed. Okay. Ethnographies. So here's an ethnography that was actually consulted in doing this post-hoc analysis, and statistical techniques in econometric modeling. So here's the regression coefficients from the econometric model that is, and econometrics has had a ton of theorizing ever since Hovelmo and the Coles Commission. Okay, so there was a little high social theory too. I've been talking about sort of hands-on theory and theory of method and maybe ethnography. Some people, those economists tend to think it's pretty low theory, but I thought it was pretty good. There's also a little high social theory too that the economists probably don't like. So from Foucault and Judith Butler, both warn you about this kind of phenomenon. So in conclusion, whether you want to build a laser or help get children better nourished in Bangladesh, you need theory, more theory, okay? And you need theories like this. You need theories of the instruments we use, theories of what methods can do, the theories that underwrite measures, the way, for instance, you design a poverty measure, theories that give sense to our concepts. That's what I worry about with Wolfgang's deductively closed formulae, that you need all of this to give sense to them. Theories that bridge between different levels of description, etc., etc. So you need huge sets of theories of all sizes and sorts. So big theory, in the sense of wide theory, is here to stay. Thank you.